Okay, so I assume everyone can see my slides right now. All right, so before I started GetML as one of the co-founders of it, I was working as a data scientist myself, and I pretty much realized in every project that I was working on full time that it's really difficult to actually turn your data in any way into something that creates business value on the other hand side. And today I want you to explain why that's the case and how we came up with a solution that we think is solving one of the really fundamental problems of turning your company data into business value. Okay, so let me start off with like a really general and broad introduction. So companies collect terabytes of data. They can store it in data catalogs, and every industry, independent of its more or less broader location, education, retail, logistics, pharma, every company has their individual data assets with all its specifics, but there's one thing in common of all these companies that are storing the data, and that's that they are storing that data in the so-called relational data format. So it's really cost and more or less space efficient way to store your data, and that's really important for the next slides that I'm talking about. So all right, so we have data, but how do we turn that data into any value? There are some ways of doing that, and one common way is by developing predictive analytics solutions for your industry. These are use cases. They are not really unique to the industry. They are sometimes can be seen in more industries, and use cases can be like fraud detection, retention management is very important, predictive maintenance also a popular one, and also some purely digital ways like programmatic advertising. And all these use cases have that common basis they are built upon, and that it's again that they draw their data from these so-called relational databases. But what's the problem with relational data? The problem is that no current forecasting algorithm that we are working with, doesn't matter if it's like XGBoost time series algorithms or some deep neural network, is actually able to work on your relational company data straight away without any help. And that's the problem that we are here addressing, and the solution that we are introducing, how to mitigate the problem that forecasting algorithms need that flat file format, so basically just a single table that contains all the important information, whereas in our data catalog is always a very problem agnostic relational data model stored in. And how do we more or less mitigate that? So how do we get our relational data in a format that is actually compatible to the forecasting algorithms of your choice? And that's so-called the process of feature engineering. So feature engineering is like an interdisciplinary process where domain experts, so basically business owners, product owners, and data scientists are coming together, and they discuss what is important for the forecasting algorithm to work on. And then, given that knowledge that data scientists have to acquire in countless meetings distributed over weeks of time, they now have to start to write individual code to more or less scramble that relational data in that flat file format. And more or less the biggest hurdle is that there are these unknown unknowns. So if neither the domain owner or the domain expert nor the data scientist is actually aware that there's one certain aspect inside your relational data model that would be important for the forecasting algorithm as well, and they don't know it, then that data is missing, and the forecasting algorithm is potentially delivering subpar performance, and everything more or less results in the big like business problem that process of manual feature engineering takes 2 to 3 months time. And even though you can generate that flat feature table, it doesn't guarantee you any business value. How come? And what could a possible solution look like? So basically, there are two ways. Either we 100% of the time guarantee that if we are going through the process of manual feature engineering, there is some business value, or B, secondly, we significantly reduce the upfront investment in like turning your relational data into something that the algorithm can understand. And as probably everyone will agree, the first one, it's not an option. You don't know that there are a lot of problems that are great data science problems where you can build really accurate forecasting algorithms for, but which don't generate any business value. That's like sometimes too completely detached problems there. But instead, secondly, we should look on the way how we more or less make that data compatible. And the solution that I'm now proposing and that we developed is basically having another machine learning algorithm go through that process of making your relational data compatible, like in a flat file format, to the forecasting algorithm. So at the end of the day, that software, these brand new algorithms that we wrote and integrated in that GetML machine learning suite help to decouple the model performance from expert knowledge. So data scientists don't actually need to know all the business specifics. They just need to be able to work with statistical algorithms, what they're actually good at. And then secondly, and that's what some of you might look forward to, is that you don't need to go through through that manual process of data wrangling anymore. That's something that the algorithm will do for you. So it basically comes up with these features that show you how you can best merge and aggregate that relational data into that file format. And then thirdly, of course, it also can help you to get a better understanding of the underlying problem by looking into the feature code. So at the end of the day, we wrote 3 slightly different algorithms tailored to more or less different types of data sets out there. And this helps you, the data scientist, and the business that wants to implement one of those forecasting algorithms to reduce the upfront investment time-wise from 2 to 3 months to just a couple of days. And to give you a better understanding, I promise you I won't go into detail. I just want to give you an idea of how the code can look like. So if you're a data scientist and you do that task of taking data from the left side to the right-hand side, you write that code. And that's a really that simple feature, but it basically gets the job done. But it's just one feature, and really good forecasting algorithms need hundreds of these features. So again, with GetML, we tasked the algorithm to find that features that are really important. And we came up with, or that algorithm searched through the relational feature space, through the best merge and aggregate operations. And that's just one feature, one of those automatically generated features of 100 that the software was basically able to generate in the same time frame. And given that this is the output, how does the software feel like? Who is it for, and how do you use it? So GetML is a software for data scientists. The algorithms, they, as briefly explained, they perform an iterative gradient-based search through your feature space, and also combines that with basic the state-of-the-art forecasting algorithms to get the whole job done. And all it needs for you to work with is like a good understanding of your relational data model. So basically what's already there in your data catalog. And then, of course, you need to have a target variable and some basic Python data science skills. And then you're set to go. And as, again, I'm a data scientist myself, I wouldn't trust these slides too much, and that's why I want to point you in the direction of our demos, where we have an interactive environment, GetML version installed that we use to showcase some standard predictive analytics problems, and that's something that was very successful here. That was basically about predicting how dirty the air is going to be in Beijing. We outperformed an approach that we developed with TS Fresh by more than 12%, and on an pure time series problem, so basically predicting how much traffic there's going to be on the interstate 95, we benchmarked our GetML features against typical time series library Prophet, and that's where we again outperformed Prophet by more than 30% on the IUC. And yes, that's nice. Thanks for your attention, and I'm looking forward to your questions.
Great, Alex. Thank you. That was really, really interesting. I think for me, you made the case even better when we, when we first discussed about it. I think that was, if I was a business decision maker with a large, or not even a large, but a data team, I would definitely get GetML based on this delivery. One question: have you studied the customer satisfaction of these developers and data wranglers, as you said? Are they more satisfied with their work as a result of taking your tool into use?
I mean, absolutely. Every data scientist that needs to write less SQL code than he had to write before is a happy data scientist. So it really helps to make machine learning more an algorithmic problem than a problem about how good or how well the data scientist understands the domain that he is working in. Because right now, if you're a data scientist that like you studied maths, you're really good with statistics, gained a good understanding of all the important machine learning algorithms out there, and now all of a sudden you assign some aerospace or some insurance prediction problem, and that's when you really have to work a lot on your basics, on the very fundamentals of that domain, to be able to prepare the data in a right way. And that's what we want to relieve those data scientists from. So it's basically like deep learning. If you want a good predictor that detects cats in your image, you don't need to have a data scientist that knows how a cat look like. It's just absolutely fine if you have a label training set which is comparable to your data catalog, and then off you go with your more or less default toolbox.
Very quickly, we're almost out of time for the Q&A, but there is a question from Suravi Suravi Roy, I'm sorry about if I pronounce it wrong, but bear with me, I'm Finnish. How do you validate the values of automatically selected features?
I mean, we can still, like, assuming that you okay, so like, as far as I understand the question, it's how do we make sure that we didn't learn any artifact or something. So it's like you could think of these algorithms a bit like a random forest that is built for relational data. So it's like a rather crude comparison, but the random forest solves that problem by just not training one tree, so basically a single decision tree, but a whole bunch of them. So with these like bagging and boosting context, you really can make sure that you have an ensemble that covers all the aspects of your data set. I hope that answered your question.
Good. Suravi can maybe comment if that was to the point, or then if we towards the end and the networking side of the event want to delve a little bit deeper on that question. Hey, thanks, Alex. That was really interesting. I think I now definitely know if I come into a client meeting where the client discusses that specific problem, I definitely know how to recommend you now.
Thanks, Rico.